Hello and welcome. In this worked example, we're taking a look at some radioactivity question, a radioactivity question from paper 2. So it's a graph of nucleon number A against proton number Z is shown in figure 7.1. See that there. Then it says the graph shows a cross labeled P that represents a nucleus P. Nucleus P decays by emitting an alpha particle to form a nucleus Q. Nucleus Q then decays by emitting a beta minus particle to form a nucleus R. And our task is to, on this figure, use a cross to represent the nucleus Q, and then label that cross Q, and then use a cross to represent nucleus R and label this cross R. All right, so go back up to this figure here. So something with 84 protons labeled P for polonium, right? Not phosphorus, right? That's polonium there. So its chemical symbol is PO, but they're just saying, well, just some random letter P to represent that one. All right, so the first decay that they said that we had to consider was an alpha decay. So alpha decay drops the nucleon number down by 4, so it'd be at 210, and it drops the proton number down by 2, right? So we lose 2 protons and 2 neutrons, so we lose a total of 4 mass units, but we drop down, 2 atomic number, two protons. And so that cross right there, right? Always follow directions. It says use a cross, right? So we're going to label that one Q. And then beta minus decay, you may recall, is when we change one of the neutrons into a proton. So beta minus decay, we're going to sort of effectively move this one up on the periodic table. We're not changing the nucleon number because we're just sort of swapping a neutron for a proton. So this one increases, and so this cross right here is the one that we label R. So pretty straightforward once we understand the reactions there. The question goes on to ask for the name of the class of particles that includes the beta minus particle. So it's an electron, belongs to the class of particles called leptons. And then the quark composition of one nucleon in Q is changed during the emission of the beta minus particle. Describe this change to the quark composition. If you recall that beta minus decay, as I mentioned a moment ago, we're changing a neutron, which is down, down, up, to a proton, which is up, up, down. And so describe this change to the quark composition. A down quark flips to an up quark. That's the change in the quark composition that sort of gives rise to the emission of a beta minus particle. Very similar to the example that we just did a moment ago. I don't know if I still have that one queued up. Yeah, this one right here. So you can kind of see that a lot of these questions, assessing the same learning outcome, kind of overlap, right? So the change to the quark structure when the neutron decays, very similar to what we just did here. And this has been another worked example with Dr. Schleif. We'll see you next time.